I'm going to show you a demo of the pod lifecycle. I am in the directory pod lifecycle in the Kubernetes course, and here I have a lifecycle YAML file. This is a deployment, and in the pod specification I have an init container. So this is the first container that is going to be executed. This is a separate container, just like I showed you in the previous lecture. So we also define an image and a command that will be executed. This container is just going to sleep 10 seconds and then exit. Then we have our main container, the lifecycle container, also image busybox, and it's going to write to a file the date, and it's going to say it's running. So the file is /timing. Then we're going to echo the app is running, and then we're going to sleep for 120 seconds. We have a readiness probe. This is also going to write to this /timing file so that we have a nice overview of the timings. The liveness probe, the lifecycle, and in the lifecycle we have a post start and a pre-stop. So these are the hooks that we're going to use, and using those hooks we can execute a command in our main container. So here we're also going to write to /timing just to see when this command will execute. And then the pre-stop is also going to write to our file, and then it's going to sleep for 10 seconds. In the init container is not going to write because that is a separate container, so we would not get that information anyways. We would have to use a volume to share information between the init container and the main containers. So let's run this, and I'm going to show you this in a split screen. So I'm going to use a tool called screen, and I'm going to split my screen. Here at the top, I'm going to run watch n1 kubectl get pods. There are no pods currently. And then here in this other screen, I will create a pod. And then I will also read this timings file. kubectl create -f of this lifecycle YAML file. I will press enter. Lifecycle created. And now we can already see that it's running the init container. So the init container, which runs first. Let me kubectl execute -it. You see now that the pod is initializing. So I will do cat timings or timing. And we already have the main pod running. So first we have running, that is the main container. Then we have post start and then end post start 10 seconds later. And now the readiness probe. So let me tail this instead. Tail timing -f. It's going to be easier. So the main container started. Now that says running. Then we have the post start that starts. So these two start together. The main container and the hook, the post start hook, start together. It takes 10 seconds. And then we have the end post start. And then after the initial delay, we have the readiness probe and the liveness probe. So those will execute. Both of them will execute as long as the main container is alive. The main container will be alive for 120 seconds. So we still have status running, which means it's still alive. We still see the liveness and the readiness probe. Just have to wait. I will just pause the video for a second and wait until the container stops. And now the container is completed. And then the command is terminated with exit code 137. So the pod has been terminated and the stop hook is also executed, but you don't see it anymore because the sleep command has been terminated. The pod is again running because remember, the liveness check will restart the container when the probe fails. So in this case, the probe failed because the command has been terminated. What's going to happen then is that the liveness probe is going to restart container. The readiness probe will make sure that the container is not in ready status, so that there's no traffic sent to the container. And when the container is started, the readiness and the liveness probe will do their checks again. And when the readiness probe succeeds, the IP address of the pod will be again added to the service and the pod will start serving traffic again. So you can use this file and execute this on your own system to see how this works. These init container and the hooks are very useful to use to execute commands at certain times of your pod lifecycle.